Okay, we're in a typical sandplain landscape for the South Stirling's region of Western Australia. We're here looking at a gravelly soil. So as a gravelly soil, you'll find this anywhere from Geraldton down to Albany, across to Esperance, and also in some parts in the countryside out towards Merredin. As you get across towards Esperance, you tend to find that there's less clay in this topsoil section and subsurface section through here. And really all I'm doing here is just demonstrating where the layers are. All you're really just looking at is where the layers change either in colour or in texture. So in this instance, for example, I can see that this is a sandy gravel that sits over the top of a clay. That's fairly straightforward. So we'll just do the first layer that I can see, which is quite easy there. There's a fair proportion of gravel in the profile. Next one is about through there. And we have this quite large chunk of clay that changes down to about 100 centimetres. So one of the things about gravelly soils is that they do present more physical constraints for production. The gravels can be quite tough. This particular profile, because it's got a little bit more clay through the profile, can also be quite compact at depth. Although as we've gone down through the profile, we can actually see that the bottom clay is quite friable. As you break it open, it breaks quite easily. And where it breaks easily, these are where roots will penetrate into the soil. Topsoil is water repellent. It's quite water repellent. Water repellence is where the water beads like a ball of water, literally, and doesn't penetrate into the soil. When you look into the subsurface in the second layer down, which is about 20 to 40 centimetres or so, 10 to 40 centimetres, you can actually see that there's quite a fine matrix of soil around the gravelly pieces, gravelly rocks that are in there. One of the things about these soils is that because of the fine matrix of the gravel, and also on some of these gravelly rocks that are in the profile, if they've got a porous outside, they can actually have quite a high water holding or water retention availability of water, but they can also hold well onto nutrients. One of the things with this profile, as you look through it, it does actually have a lot of already roots that have managed to penetrate through the profile. Down here there's actually quite a mass bundle of fine roots that have penetrated down to a metre 10. And it's quite a good sign to be able to see in the soil that roots have made it that distance. A feature of the profile in this particular instance is the presence of old bush roots, remnant vegetation. Here we have the bolus of the root. There's some other roots that probably go around it. But in this instance, it does add some biology and some preferred pathways for drainage and nutrients and other roots to follow. And this bush root actually penetrates all the way down to about a metre 10, so that's quite a fair penetration. And you'll find, and you can probably see it, that other roots have actually gone alongside this root. So again, existing roots that are in the profile present an opportunity for roots to follow alongside and also for biological development. A common thing that a lot of farmers like to do on these gravelly soils, because of the compaction layer, is to deep rip them. Deep ripping can be a win-lose situation. Sometimes if it's already got existing remnant roots through there, there's a whole microcosm of biology that's going down through the profile. In a lot of respects, you don't really want to disturb that. But if that's not present, and it's definitely a compacted soil, and it's not a sodic soil, then, and it's deep enough, sometimes ripping can be quite beneficial for these soils. The other thing of interest is looking at different faces in this soil pit. This second clay layer, you can actually see that the clay surface is quite wavy. When you get that wavy surface, it's a good surrogate or a good indicator to say that the soil is sodic, so that's a high exchangeable sodium percentage. The issue there, of course, is you get dispersion in your clay. The clay will slump. Often in a waterlogged situation, the surface of that clay will seal, and that presents a whole set of other issues. The two most beneficial measurements are pH and salinity. And I don't envisage salinity to be an issue on this soil because it's high in the landscape, it's a relatively well-leached profile, but the best way of being able to determine the pH is to use a universal soil pH indicator, which we just essentially spray on the profile. The significance of pH in a profile, if it gets down to more your orangey type sort of colours, and where there's a little bit of clay in the profile, you tend to get aluminium that becomes dissolved moving through the profile. Aluminium in soil is a bit of an issue, particularly causing aluminium toxicity. In this soil, I don't imagine it to be too much of a problem, but it's something to still watch out for.